Okay, gas stoichiometry. Basically, there's two types of problems we can give you. In one case, you will be given liters and asked to find something else, in which case you're going to start with the ideal gas law and then use stoichiometry. Or you can be asked to find liters, in which case you're going to kind of do the opposite. You'll start with stoichiometry, get an answer in moles, and then plug that answer into the ideal gas law. When I read this problem, it clearly says how many liters of hydrogen. So I am asked to find liters. So this type of problem, I'm going to start with stoichiometry first, get an answer in moles, and then plug that answer into the ideal gas law to get volume in liters. So here we go. I'm going to start with 35 grams of calcium because that's what they give me in the question. Let me read with red. So we're going to do 35 grams of calcium. The first thing I'm going to do is convert to moles. It's always useful for me to convert to moles because I can look at my mole ratios from that point. 40 grams of calcium for every 1 mole. Awesome. Where did I get that number 40 from? That's the molar mass off the periodic table. And now I can go ahead and look at my mole ratios. I'm going to continue to follow my units. If I have moles of calcium up top, that means I have to have moles of calcium down below to cancel. And what do I want for my unit up top? Well, the problem's asking me to find liters of hydrogen. I can't get to liters of hydrogen just yet, but I sure can get to moles of hydrogen by looking at my mole ratios. So I'm going to go back to my chemical equation. Actually, really, that should have been the first step. I apologize. The first step in all stoichiometry problems is to balance your equation. So double check, make sure you got a balanced equation before you look at your mole ratios, which in this case I already do. So where can I find my mole ratio here? Well, there's a coefficient of 1 in front of hydrogen, and there's a coefficient of 1 in front of calcium. This is a 1-to-1 ratio. So I'm going to plug those in, and I'm going to go ahead and find my answer. It's useful for me to find my answer in moles of hydrogen here because I have a place to plug that in into the ideal gas law, which I'll show you in just a minute. So how do we solve this? Punch in your calculator 35 times 1 times 1, and then divide by 40, divide by 1. You should end up with 0.875 moles of hydrogen gas. And it just depends on how you round here. You might end up with a slightly different answer than me. If you decided to round, that's okay. The world's not going to end. Now we're going to use the ideal gas law. PV equals nRT. Wonderful. If you read the problem's going to give you a pressure. It will give you a temperature, which I see up here in my problem. And what did we just calculate? Well, we just calculated moles of H2. Why is that useful to us? That's useful because now I can plug it into the ideal gas law for the variable N. And now I'm going to be able to calculate volume, which is what the question was asking me to begin with. So let's go ahead and plug and chug here. From my problem, I see that the pressure was 3 atmospheres. I'm looking for volume. That's my unknown. The moles we just calculated, that's what we just spent time calculating. That'll be moles. The ideal gas law constant R is always the same number, 0.0821. And yes, it has funny units. I know my students don't like these units. I know they don't like writing it out. I know it's scary. Some of my students even think that this is a whole nother equation on its own, and they try and plug in values for liters and atmospheres here. Don't do that. This is simply a unit. I know it's scary. I know it looks nasty. I'll show you how it cancels in just a minute. And then please don't make my favorite mistake. If you accidentally plugged in 45 degrees Celsius here right from your problem, please cross that out with a big fat X. That is my favorite mistake. You must convert to Kelvin. So instead of using 45, I'm going to add 273 and plug in 318 Kelvin. And now I can go ahead and solve for my unknown. To get my volume all on its own, I'm going to have to divide both sides by 3 atmospheres. That way it'll cancel over here. 3 atmospheres. Okay, now watch how my units cancel. My moles will cancel, my atmospheres will cancel, my Kelvin will cancel. What unit am I left with? I'm left with a unit of liters, and that's for my volume variable, which makes sense. So that's the reason why we need that really scary unit on that gas law constant, so it can cancel out. So punch in your calculator, 0.875 times 0.0821 times 318 divided by 3. You should end up with, for a final answer, I guess I'll just box it in over here, I'm running out of space, with a volume of hydrogen gas at about 7.6 liters. It just depends on, again, how you round it for moles or how you round your final answer. It should be somewhere around there. Hope this video helped. Best way to study is to just practice. Practice, practice, practice. Get more gas stoichiometry problems and then just try and solve them over and over again. Good luck.